All right, we are doing chapter 11-4 today. And 11-4 is quadrilaterals. So first I want to define what a quadrilateral is. And there are three specific, specifications that need to be present in order for us to call it a quadrilateral. So first we have that it must be a closed figure. Okay, number one, it must be a closed figure. And what that means is it can't be something like that. Okay, it has to actually be closed. Okay. The next thing is that it has to have exactly 4 sides. And it has to have exactly 4 angles. And those 4 angles will add up to 360 degrees. Okay, so that'll come into play here in a little bit when we start looking for finding the value of x when x is one of the angles. All right, so let's scroll down here for just a minute and let's talk about some terminology here. So in your notes, these are examples here of quadrilaterals, okay, on this side. So notice that each one of them has 4 sides. It has 4 angles, okay, and it is a closed figure. Again, 4 angles and 4 sides. And even this very weird shaped one here has 1, 2, 3, 4 sides, and it has 1, 2, 3, 4 angles. So those 3 are quadrilaterals. Over here, we've got some examples of non-quadrilaterals. This one, it's got 1, 2, 3, 4, 5, 6 angles. This one has 1, 2, and then, yeah, definitely not 4 sides, 4 angles. And then this one has 5 angles and 5 sides. So there is some examples of what quadrilaterals are and not quadrilaterals. Quadrilaterals, when you describe it, you describe it by its vertices or by its angle sides or angles. So this would be quadrilateral ABCD. And when you are listing its sides, you just like in triangles, you put a straight line over AB, BC, CD, and DA. Its vertices and its angles are the same thing. Okay, its vertices are the 4 corners, and then that creates 4 angles, and each angle, you always notate it with the angle symbol and then the letter. So this is angle A, angle B, angle C, and angle D. When you bisect a quadrilateral, like this one here, with that red dotted line, it does actually create 2 triangles. And we know from earlier this week that the interior angles of 3 triangles equals 180. Right? Well, because a quadrilateral can be separated into 2 triangles, the interior angles of 2 triangles would be 180 plus 180. Therefore, the interior angles of a quadrilateral equal 360 degrees, which we already mentioned up top. All right, so when you're classifying quadrilaterals, a couple of things I want to point out here. One is all of these on the screen right now are quadrilaterals, okay? But this one is just kind of a generic quadrilateral here. There's nothing really special about it. Then we get some special quadrilaterals. So the special ones, let's see, losing green. We have a trapezoid, we have a parallelogram, we have a rhombus, a square, and a rectangle, okay? Those are your special parallelograms. And notice under this tip box over here on the left, it says when you're classifying quadrilaterals, okay, the diagram at the right begins with the most general quadrilateral and ends with the most specific. When you name your quadrilateral or when you classify your quadrilateral, you're going to use the most specific when possible. So you'll notice in your homework it says the best classification. So if you were to, in your homework, if you were to name this one here just a quadrilateral, well, it is a quadrilateral, but specifically it's a special quadrilateral. So the proper or the best classification would be a square. Okay, so you can't just call them all quadrilaterals. You have to get specific if you can. So if it is a trapezoid, a parallelogram, a rectangle, a rhombus, or a square, you need to be specific with the classification. If it doesn't fit one of those 5, then you would just stick with the generic quadrilateral classification. Notice on a trapezoid, these arrows mean parallel lines. So on a trapezoid, you have one pair of parallel lines. A parallelogram, you have 2 pairs of parallel lines of opposite sides, and these little slash marks tell you that these sides are congruent. With a rectangle, notice that it creates 4 right angles, so that is a rectangle. A rhombus has it's a parallelogram with 4 congruent sides, so that's what those 4 slash marks mean. And then a square, of course, a square has congruent sides, and it also forms 4 right angles. So those are your special quadrilaterals, and when you are classifying quadrilaterals, make sure and use the most specific or special term possible, and then if it's not a special one, then just call it a quadrilateral. All right, so let's look at your notes here. I would like for you, if you're at home, you're just going to have to sketch a couple of these. So we're going to focus in here on number 1. And really, before I focus in on that, I want to look at your directions, because this will match what your directions look like in your homework. So it gives us 2 things. 1, it says find the value of x. Okay, that's step 1. Then it says find the missing angle measurement or measures. Well, that seems like that would be the same thing, but in our second example, you'll see that sometimes you can be missing more than one angle. And so the value of x is not necessarily the value of your angle. And we'll kind of get into that here in a second. So when we do this, we're going to do 2 things. We're going to find the value of x, then we are going to find the missing angle measures. Okay, those are the 2 things we're going to do for each one of these, and what you'll do in your homework. All right, so for number 1, this is pretty basic, right? We've got 3 angles given, we're missing 1. So we can kind of do this almost in a more generic, we don't even have to use algebra on this first one. You certainly can. You could do 65 plus 50 plus 130 plus x equals 360. Combine like terms and solve for x. Or kind of like we talked about in the triangles, you can just really do this very generally. You could say that the 3 angles given are 130 plus 50 plus 65, right? And when you add up 130 plus 50 plus 65, you get 245. So I know that 3 of the angles equals 345. I can subtract that from 360, and I can get that x equals 115. So that is that first step of finding the value of x. Okay, done that. Step 2 is find the missing angle measures. Well, in this particular one, the only one missing is x, and x equals 115. So inside my quadrilateral, I'm going to put 115 degrees. So I've found the value of x, and I have placed it in the proper place inside the quadrilateral with the proper angle. All right, now let's look at number 4. Number 4 can't just be done kind of this basic add up 3 sides, subtract from 360, because you'll notice the difference is that we actually have 3 angles that have an x. So we do need to write this out using algebra. So we know that angle 1 plus angle 2 plus angle 3 plus angle 4, right? Those are the 4 angle values, 8x plus 2x plus 10x plus 60. And we know those all equal up to 360. Well, some basic solving equations steps here are that first we combine like terms. So we're not subtracting it to the other side. We're not doing anything like that. We're just simply writing 8x plus 2x plus 10x in a simpler way, and that equals 20x. And then just write the rest of the equation here. And again, we're just going to do the next basic step, which is we're going to subtract 60 from each side because we want to work towards solving for x. And that gives us 20x equals 300. And then I'm going to divide the 20 off of the x. And if I do it to one side, I do it to both. And that gives me x equals, and then 300 divided by 20 equals 15. So the first step, solve for x. I've done that. X equals 15. The next step is I'm going to go over to my actual quadrilateral here. And with the knowledge that x equals 15, I'm going to solve the equation in each corner or each angle. So I know that this angle is 8 times x, and I now know that x equals 15. And when I take 15 times 8, I can now fill in that this angle is 120 degrees. Coming over to the next one, I'm going to go 2 times 15, or 2 times x, and 2 times 15 is 30. So I know that this angle measures 30 degrees. And on this last one, I've got 10 times 15. And so I know that this last angle measures 150 degrees. So when you're done, you should have an exact measurement written in degrees in all 4 angles for the quadrilateral. Okay. So no matter which ones are missing, as long as they all are written in terms of x, you can just add all those x's up together and then solve the equation. Okay, so that is where we're going to kind of end with the note-taking session. Don't need to do a whole lot of examples of these. Now let's switch over to your actual assignment. Okay. So for your assignment, I want you to do numbers 1, 5, and 9. Okay. For right now, just start with that. We're going to do numbers 1, 5, and 9. And I want you to pause the video. I want you to try 1, 5, and 9 on your own. And then when you're done, unpause the video and then check to see if you got the same answers that I did. Okay, so now that you've unpaused it, hopefully you have the work done for 1, 5, and 9. So I'm going to go ahead and work these out. Number 1 is a very basic one. Again, we have 3 of the 4, so we can write it out algebraically, or we can just simply kind of do it in a more simpler way of thinking, which is that we're going to add up those 3 sides, and we're going to get 105 plus 75 plus 40, and that's going to give us 220. And then we are going to subtract 220 from 360, and we're going to get that x equals 140. So we have found the value of x, and I'm going to go into my quadrilateral, and I'm going to actually write in the proper corner that x equals 140 degrees. So that one is one that doesn't necessarily require the algebra formula, although if you wanted to put the algebra formula in there, and do 105 plus 75 plus 40 plus x equals 360, you certainly can, because you're in essence doing the same thing. You'd combine like terms and get 220. You'd minus 220 from both sides, and you would get x equals 140. So you're going to get the same thing either way. All right, so for number 5, hopefully you remembered that when there is not a number behind a variable, it is actually understood to be a 1. So right there, we're going to make this a 1x. And so we are going to add together 2x and 1x and 3x, right? We're going to write this all out. So we've got 2x plus 1x plus 3x plus 60 equals 360, right? That's side or angle 1, 2, 3, and 4 all added up together, we know is going to total 360. Now I'm going to combine like terms before I do anything as far as moving things on either side of the equal sign. So 2x and 1x and 3x equals 6x. And then I'm just going to write the rest of the equation. And I'm going to start solving for x. So I'm going to subtract 60. And remember, whatever you do to one side of the wall, you do to the other. You got to keep those scales balanced. And so that and that zeroes out, and I'm left with 6x equals 300. And then I'm going to divide by 6 to get that x by itself. Whatever I do to one side, I do to the other. And so x equals 50. All right, so that's step 1. We solve for x. Now we got to go up and we actually have to plug in what each angle equals. Well, this first one, 1x, is easy. That one is just 50 degrees. 3x is 3 times 50. And 3 times 50 is 150 degrees. And then down here, we've got 2 times x, or 2 times 50. And so we know this bottom angle is 100 degrees. Okay. For number 9, same idea. We are going to add 3x plus 2x plus 105 plus 130, and we know that all 4 angles equal 360. And now we've got a couple of things to combine. We've got our x's to combine, and we've got some numbers to combine. And when we do that, 3x and 2x can be combined as 5x, and 105 plus 130 is 235. Now notice I didn't subtract anything from both sides of the equal sign, because on this step, all I'm doing is combining the things already on the left and writing them in a more simplified combined manner. So instead of having 3x and 2x, I can rewrite that as 5x. And I haven't changed the value of my equation. So I haven't kind of changed my scale here at all. Now I'm ready to start actually moving things on the other side of the equation. So I want this 235 off of this side. Oops. And if I do anything, remember the equal sign is kind of like your scale or your wall. If I do it to one side, I have to do it to the other because I'm changing the value of the left. So I need to change the value of the right in the same way. So those two zero out and I'm left with 5x equals, and 360 minus 235 is 125. Now I'm going to divide 5 off of the x. Whatever I do to one side, I do to the other. And I end up with x equals, and 125 divided by 5 gives me 25. So there's my value of x. Now I'm going to go up here into my quadrilateral. And on this first one, I get 3 times 25, which tells me that this angle values in at 75 degrees. And 2 times 25 is 50. And so this angle is 50 degrees. And of course, if you ever want to check your work, you can add 105 plus 130 plus 75 plus 50, and those will all total up to 360. All right, the last thing I want you to do is, well, actually, I'm gonna come back to that. So then let's come down here. So for your homework, I want you to classify, right? Classify each quadrilateral, and notice it says using the best. Okay, so yes, all 6 of these are quadrilaterals, but all of them but one, hint, hint, are special quadrilaterals. So you need to give it the most specific name possible. And then if it doesn't fall under the category of one of the very special ones, then you would just simply call it that generic quadrilateral. Okay. All right. So I want you to do those 6. And then I also would like for you to up here, I would like for you to do the odds. Okay. So in this section here, oops, of the ones that are left, okay. Oops, I went back over to the notes. Sorry. This section here, I would like for you to do the odds that are remaining. So you've already done 1, 5, and 9. So now that means you would do 3, 7, and 11. And then you should have already done this, but then you will complete all of these by naming them or classifying them by the best description possible. And then here at the bottom, do all of these. And you're just thinking through, is a rhombus is a square? Is that sometimes, always, or never true? Okay, a square is a parallelogram and a parallelogram is a square. So think through that and try to answer that sometimes, always, and never. If you have any questions, shoot me an email and I'll be happy to help. Otherwise, I will see you back in class when you return to school. Have a great weekend.